Welcome to Emtron Training Part 26. In this training tutorial, we're going to be taking a look at a hybrid airflow modeling strategy we have in our Emtron ECU. We're also going to be taking a look at alternative tables that we can use to act as an offset for fuel mass or air mass determination. So if we're finding something wrong either in our fuel modeling or in our airflow modeling, we can use these sub-tables to make a correction to get things back in line. We're going to have a lot to talk about. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our hybrid fuel modeling options we have in our Emtron. We're also going to be taking a look at some ways we can correct our fuel mass or air mass calculations if we're finding there's some kind of a deviation going on. We have some subtables that we can do some corrections in. Now this is going to be definitely high level type of programming and calibrating within your Emtron, but I wanted to include it within our training tutorials in case you get into the situation where you want to work with multiple different types of airflow strategies, or being able to go in and correct your fuel or airflow modeling through a separate subtable. First thing we want to take a look at here is the options that we haven't talked about yet within our fuel modeling in our Emtron. And that's going to be here, specifically, if we jump into fuel and we jump down in here into our blend table, so we see our fuel model blend table. This allows us to do a similar kind of concept as our air modeled option we talked about in our last tutorial. The air modeled option allows us to blend between two different airflow strategies and combine them into that runtime channel called air modeled. Now, with our fuel blend table, we can combine things like our throttle mass flow and speed density, or throttle mass flow and air model, which is even more confusing because technically we can have up to 3 different ways we're representing our airflow strategy. We can do throttle mass flow, speed density, and mass airflow all at the same time, depending on how you configure and set up these tables. Now, the traditional way we work with our fuel blend model table here is going to be throttle mass flow and speed density. We don't need to rely on the air model parameter to do that. We can actually do that right into our fuel model blend table. So let's go and take a look at how we're going to be accomplishing this and then how to set this up here, and then some of the other options we have for programming. First thing we need to do in order to work with our fuel model blend table is jump into config, jump into fuel, and then go here into fuel main. Under fuel main, we specify what we want our fuel model setup to be as. Now in here, we have it set on speed density map pressure. So we can see right now it is the speed density option, which allows us to work within a volumetric efficiency table and do all that calibrating and tuning we've talked about to estimate the air mass coming into our engine. We know that we have other options here, mass airflow, if we have a map sensor enabled. And then we have our other options down below. We've talked about in the last video implementing an air mass modeled into our actual fuel modeling setup here. If we're doing the air mass modeling, combining parameters like throttle mass flow and speed density, or throttle mass flow and a mass airflow sensor, we're able to blend those into that runtime value just called air mass model, and we're able to bring that into our calculations and build a table based on that. Now, we can take this a step further, and let's just put aside air mass model right now. Let's talk about our throttle mass flow. We've had a specific video on throttle mass flow, what that represents. We know that it's superior to something like speed density tuning within part throttle conditions because it's going to be directly taking into account what the throttle movement's going to be doing and relating back what that estimation of airflow is going to be. So we have a superior transient type of fuel calculation built right into the throttle mass flow, and that's definite advantage for working with that. Now, typically, if we're working with throttle mass flow, we're stacking it or combining it with another airflow strategy, such as speed density that's extremely common to work with. We can take a look at our options here. We have an option 3 and an option 4. In our option 4, this is probably the most commonly used for that fuel model blend table. This is going to be throttle mass flow and speed density map blend. In this situation, it takes a look at what values we place in that fuel blend table to bias between either throttle mass flow or speed density. Now we actually have to go in and calibrate and tune both of these in order to work with them, but this will allow us to split the airflow strategy in a percentage or biasing way that we can work with that table.
Similar kind of concept to the air.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.